The universe is filled with structures that are both vital and extraordinarily complex. But did you know that these structures do more than just dazzle us with their cosmic beauty? They serve as the birthplaces, transformation centers, and distribution hubs for the cosmic elements that form the very physical foundation of our existence. If you've ever looked at the night sky and marveled only at the stars' light, you're missing the bigger picture. This video is here to show that nebulas are not merely breathtaking celestial vistas. They are key players shaping the universe and our future. Nebulas are enormous clouds of gas and dust floating in the interstellar medium. They are composed primarily of hydrogen and helium, but they also contain microscopic dust particles made of silicates, carbon, oxygen, and other heavy elements. While a single nebula can stretch across light years, the majority of its mass is essentially empty space. Their densities are so low that they are many times less dense than the best vacuums we can create in laboratories on Earth. This makes it almost impossible to compare a nebula to anything in our daily experience. Interestingly, the dazzling glow we see from many nebulas does not usually come from the nebula itself. Their light often originates from nearby hot stars emitting ultraviolet radiation that ionizes the gas, or it comes from light reflected by dust particles. In other words, the cosmic splendor we perceive is largely a product of indirect interactions. This reveals a subtle but important truth about the universe. The greatest beauty often arises from complex processes hidden beneath the surface. Nebulas play diverse roles in the cosmic element cycle, and each type of nebula represents a different stage in this cycle. Emission nebulas. These are clouds of gas ionized by high-energy ultraviolet photons from young, massive O and B-type stars. Hydrogen atoms lose their electrons, and when they recapture them, emit characteristic red H-alpha light. Emission nebulas are active star-forming regions where high energy and gravitational instabilities trigger the inevitable collapse that leads to the formation of new star systems. They are essentially the wombs of stars, showing us the universe's ongoing process of creation. Dark nebulas. These clouds are dense and cold enough to completely block background light. They provide the low-temperature environment necessary for the formation of pre-stellar cores. Dark nebulas are the universe's silent architects. They don't emit light, but they create the conditions for stars to be born. Though hidden from plain view, astronomers can detect them by the way they obscure the starlight behind them. Reflection nebulas. These nebulas shine by reflecting the light of nearby stars. Because they scatter shorter wavelengths of light more efficiently, they often appear blue, a phenomenon caused by Rayleigh scattering, the same principle that makes Earth's sky look blue. Reflection nebulas provide a visual record of the local distribution of dust and elements, like cosmic fingerprints left behind for astronomers to study. Planetary nebulas and supernova remnants. These are the true agents of universal element enrichment and distribution. Planetary nebulas. These form when medium-mass stars like our Sun reach the end of their lives and slowly shed their outer layers into space. This process releases carbon, nitrogen, oxygen, and other life-critical elements back into the interstellar medium. A star's death here is not an end. It is a chemical inheritance for the next generation of stars and planetary systems. Supernova remnants. These are the violent final explosions of massive stars. Supernovae are the only events in the universe capable of producing elements heavier than iron, gold, platinum, uranium, and more, through a process known as rapid neutron capture, or the R process. The explosion propels these heavy elements and the star's outer layers across space at incredible speeds. Remnants like the Crab Nebula serve as distribution hubs for heavy elements, without which planets, rocky worlds, and life itself could not exist. Simply put, the gold in your jewelry or the uranium in our technology comes from stars that exploded billions of years before the Earth was born. The truth is, we are composed of the nuclear remnants of multiple generations of stars that lived and died before our sun even formed. This elemental heritage is an unavoidable, immutable fact. Our very existence is the result of a chain of stellar life cycles, explosive deaths, and the environments created by nebulas. Every nebula we observe today will either become the cradle of new star systems billions of years from now, or stand as the final chemical testament of a dying star. The universe is not static. It is in constant, inevitable, and vast transformation. Nebulas embody this endless cycle: formation, life, and inevitable distribution.